Assalamualaikum everyone. I'm Maitaz Ronon. Today I'm going to discuss about the mesh problem which is implemented in Python. So let's get started. So firstly, I have defined a class called node. In this case, it is keeping we are just keeping the track of this state, and that's the parent state. That's the parent state. In other words, the state is before and the state and the action. In case we are not keeping the track of the path cost, because we can calculate the cost path at the end after we found our way to the initial state to the goal. I would like to create an object to store all the frontier data, which is here. Frontier data, which is otherwise it's known as method of on that object. So I can use to manipulate the object using the methods. I have functions that is initially creates a frontier, and that I'm going to represent that the frontier function with a list. Okay, there is nothing in my frontier to begin with, so I have an added function that adds something to the frontier. Here, this is the function by appending it to at the end of the list. I have a function that checks if the frontier contains a particular states. This is here. After that, I have implemented an empty function. It checks if the frontier is empty. If the frontier is empty, that means the length of the frontier is 0. And then I have a function for removing something, which is here, and so that I can check it first. But otherwise, if the frontier isn't empty, so I have to recall that I am implementing this frontier as a stack. Okay, a stack has a data structure of last in first out, which is LIFO, which means the last thing I added to the frontier. It will be firstly out from the frontier. So what we can see here, I have removed the last item from the list here, from the list here, and if I do index into the Python list, while indexing in the Python list, it is always -1, because that gets us to the last item in the list. Since 0 is the first item, the -1 kind of wraps around and gets us to the item last item of the list. Okay, now we have another function like updated, kind of, it's like kind of updated frontier. So we have that the node, we call that node as a update frontier on the line 32. Okay, this key frontier is implemented for good measure, and an alternative version of the same thing called, as it is the name has given, is queue frontier. It inherits from a stack of the frontier, meaning it's going to do all the same thing at the stack frontier did. Okay, just for a reminder that I have implemented this to update the self frontier list. Okay, this is the current value, and the current value will be update this self frontier part. Okay, and I have already explained this part. There is another function called another thing about this function is, instead of removing the end of the list the way we do in a stack, we are instead going to remove from the beginning of the list of self frontier dot zero. Okay, this one self frontier dot zero will get me to the first node of the frontier. Here we have used another type of data structure, which is the first in first out. Okay, like FIFO, and it's going to be the one that will return in the case of a key frontier function. So under that I have a function called maze. This is going to handle the process of taking a sequence, a maze like text file, and figuring out how to solve it. That's the thing of the maze function. I have defined the height, weight, and other objects here. So moving on to the next part, the most interesting part is the solve function. Okay, here is the solve function, where the solve function is going to be figure out how the actually we will get from the start state to the goal state. Okay, here we will see the implementation of the exact same idea we saw on the up there. So we are going to keep track how many sets we have explored. Just we can report the data later by start with the node, but here I start with a node just to represent that the start state. Represent the node with a start set, and the start state with a frontier that will the case of a stacked frontier, and the given that I am treating my frontier as a stack. The algorithm I am using here is now depth first search for DFS use as a stack as its data structure, and initially the frontier is going to contain the start state. So we initialize the explored state that initially is empty. Okay, this is the start state, and this is the number explored, which is firstly empty, and this is the start state, which is firstly is going to be the empty or the zero, and we are here using the DFS data structure. So moving on, here is the loop. That notion, the repeating that's work is the notion of repeating the same thing again and again. Firstly, if we check if the frontier is empty by calling the empty function, that will saw the implementation of that we have seen the implementation of it moments ago, and if the frontier is indeed empty, we will go ahead and raise an exception or a Python error, which is defined here. Okay, I have to take a break to check if the video is going correctly or not. Excuse me for a second.